I'm Jennifer Waters. I work at the Met Office, and I'm going to talk about synergy with modelling from the perspective of data assimilation and ocean forecasting. I'm going to start by talking about how the Ocean Sites Network is used at the Met Office. So FOAM is the Met Office's forecasting ocean assimilation model, and the products from this have various applications. They're used in shipping, search and rescue, the oil and gas industry, Royal Navy operations, the Copernicus Marine Environment Monitoring Service. They're used to initialise the Met Office's seasonal prediction system, for climate monitoring and for research purposes. And the ocean site temperature and salinity profiles are routinely assimilated in FOAM. We use a 3D VAR data assimilation system with a 24-hour assimilation window, and we currently assimilate daily mean profiles from the moorings. Below, I've got a couple of figures which just show a snapshot of the moored buoy observations assimilated on one day. So this was for 2 days ago. So you've got temperature on the left and salinity on the right. So as well as being important for data assimilation, the Ocean Sites Network is also really useful for model validation of temperature and salinity and currents. And it's really important for calibrating, developing and improving our system. And ocean site moorings are specifically important because they provide accurate and high frequency sampling of specific events, and they provide us with this long time series, which is really useful for consistent assessment of long reanalyses. For example, looking at trends. At the Met Office, we've in the past done observing system experiments where we've withheld TAU and Triton observations to look at the impact, and that showed a significant localised impact on temperature and salinity RMS error when those were withheld. We also took part in the Ocean Reanalysis Intercomparison Project, ORIP. This was a multi-model ensemble, and this showed that uncertainties in the ocean reanalyses are partially linked to the data counts of the TAU moorings in the tropical regions. As well as being used for assimilation in our FOAM system, the mooring data are also assimilated in the coupled NWP system, which will become operational at the Met Office in 2021. This will be providing operational global weather forecasts from a coupled ocean atmosphere sea ice land model with coupled data assimilation. And thinking about coupled data assimilation, well, the co-located ocean and atmosphere observations that you can get from these type of platforms are really useful for coupled data assimilation. In the past, we've used these to assess potential cross-covariances between ocean and atmosphere variables. So now thinking about the uptake of observations in the ocean modelling community. Presently, most systems assimilate satellite sea level anomalies, satellite and in situ SST, in situ temperature and salinity profiles, and some also, like the Met Office, assimilate sea ice concentration. But increasingly, I think people are interested in glider assimilation. This is useful for measuring fronts and can provide us with targeted sampling. Sea surface salinity products is an area that's becoming more that there's more interest in. So, for example, SMOS and SMAP. Satellite surface currents in the future, these could be used for both assimilation and validation. So, for example, SCIM if that goes ahead. Wide swath altimetry, for example, SWOT. This will provide us with increased coverage and better sampling in shelf seas and coastal regions. Also, the assimilation of deep Argo will help with constraining the deep ocean, and I'm sure that in the future there'll be more assimilation of biogeochemistry observations. And I just wanted to point out that we're part of the Ocean Predict community, and part of the Ocean Predict remit is to provide feedback from ocean prediction systems to the ocean observing community. So this is something that we are really interested in and quite engaged with. So thinking about research applications in space in the next 10 years, well, moving towards more fully coupled atmosphere, ocean, sea ice, wave, land systems. This poses some new issues for us because generally coupled systems have a shorter assimilation window. So for the Met Office, it's a 6-hour window. And that means that the timeliness of observations becomes even more important, more crucial. Thinking about data assimilation systems, we'll probably be moving towards more ensemble, 4D VAR or hybrid approaches. These will hopefully help us to optimise the observation use. It might allow us to make better use of the high temporal resolution of mooring data, and it will produce better error estimates for our systems. Assimilation of new data types, so for example, satellite surface currents. Higher resolution models, these pose issues for both the data assimilation and validation. As we go to high resolution, both of these things become more complex. And improving data assimilation at the equator. This is currently a region where we struggle a little bit with the data assimilation. It's one of our weaker areas, really. I think we need to understand a bit more about the balances and how we use those in the data assimilation to make sure that we get good assimilation in those regions. So some suggestions for bringing modelling communities and observationists closer together. Coordination in observing system simulation experiment studies. These would be useful for optimising the design of future observing systems. Better sharing or more sharing of data assimilation system outputs with the observing community. This is something that the Ocean Predict community is interested in. So looking at maybe sharing increments, the innovations, which are the observations background difference, and in-house quality control information. And something else that might be of interest is better understanding of best practices for model validation and more development of flexible validation tools. This could really help make validation techniques more accessible and consistent within the modelling community, and might extend the amount that these observations are used in that way. So finally, just some recommendations for the Ocean Site network. We'd like to see that the current network is maintained wherever possible so that we keep those long time series. We're also very interested in timeliness, robustness, and providing information on quality control and errors. So I've already talked about how important timeliness is going to be for coupled systems. Improving sampling in poorly sampled regions and expanding the network of velocity observations would be really useful. Those observations are really useful from a validation point of view, but in the future they could also be really useful for data assimilation potentially. Thank you.